Good morning. We're here in Baja, California Sur, Mexico, looking at a beautiful sunny day. Pretty common down here to get full day of sun. We've got our approximately 1 kilowatt of power system. We've got 8 panels, 140 watts, 1120 watts, about 1.12 kilowatt system. And that's going to gather energy the whole time that the sun's shining on the system. So with about 11, 12 hours of sunlight, that roughly comes to about 5 to 6 noon sun hours. A noon sun is a definition just kind of like when the noon sun is hitting the panel, that's a certain amount of power. And when through the day you get about 5 or 6, early in the daytime, like you're getting 10, 20% of the power that you get at noon. So looking at 5, 6 noon sun hours on a 1 kilowatt system, and then that's 5 to 6 kilowatt hours of energy. So that's energy. So that's power is volts times the amps, and the energy is through time. And then in terms of what becomes usable for us, we're looking at just about half that. With a battery-based system, you're looking at like 55, 60%. With just a grid tied, you're looking more like 75, 80%. There's more inefficiencies in a battery system because batteries are a big loss. Like inverter inefficiencies, maybe 10% wire loss. Like you lose power all the time, but like you're mostly, with our system, losing it in the batteries. So here's one single 140 watt panel. And each of these is made up of all these little cells. The cell is outlined in black. So you can see kind of right there is one cell. And I always like to say, it's nice to wipe off some of this dust. And, however much you feel like cleaning your panels is great. But with the, when you start getting physical hard shading in a cell, like a bird shit, one bird shit in this cell is going to like derate the entire string by a certain amount. And then like another bird shit in this cell, it's not going to lose any more power. Another bird shit in this cell. So you could have bird shit in every single cell, and you still are having the same loss as one bird shit in one cell. So once there's 2 bird shits in a cell, I always say, clean your panels. Clean the entire array. Because then you're like looking at, if you want to get up here and clean your panels every time there's any bird shit, great. But if you want to, not be so OCD, you can clean it when there's 2 bird shits in a cell. So that's our array, and this array then comes through this tube. We got 2 strings of 4. So we have 4 wires coming out because there's the positive and negative coming out of each of these 2 strings, and then they're coming through here into this combiner box, and then from the combiner box, just 2 cells, 2 wires, slightly larger wires, are going down into the charge controller, into the control room, through all the solid state electronics, into the battery, back out of the battery, into the inverter. So that's basically the array. There's not a lot of maintenance that you need to really think about with the array. There's the cleaning them off. That's going to help how much energy you get from the sun. So some of the key concepts are like, the power of this system is 1.12 kilowatts. The energy is how many noon suns you get. So like, we're super lucky down here in Baja. We get a lot of noon suns every day. So our battery bank can be smaller than one in, say, the States, where you might have 2-3 days where you're not getting much sun. You need bigger batteries to keep you going through that entire those days of autonomy where you want to be running primarily off your batteries. The only other feature of an array is you can see these are flat. We just hit the spring equinox, and so because the sun's arc is more almost directly overhead, this is how we hold them basically from the spring equinox until the fall equinox. And then when fall equinox to spring equinox, we lift them to 38 degrees. Standard rule of thumb is whatever your latitude is, on the summer solstice, you want to do latitude minus 15. We're here at 23 degrees right on the tropic, and so we do about 8 degrees through the spring and summer, and then we do latitude plus 15. We do 38 degrees through the fall and the winter, and we're angling our day so that the power is a more direct hit when the sun's lower in the sky. Yeah, that's looking good.